Hello everyone, let's solve an easy problem today. In this question, we are given two events and their timings which are inclusive. We'll understand what inclusive means by looking at the example. And given these event timings, we have to check if there is a conflict. Let's look at the example. Event 1 starts at 1:15 and ends at 2. And event 2 starts at 2 and ends at 3. Since the events are inclusive, we have to consider both the start and the end timings as part of that event. Hence, there is going to be an overlap at 2. So the output is true. Let's try to come up with a solution for this. Let's consider two events with a conflict on the number line. If we look at the overlapped regions, there has to be an element x which is common to both the events. This could be written as x is between the start and the end time of both the events. If we look at S1 and S2, we see that the overlapped region starts at S2. In fact, it starts at the start time which is greater. Similarly, looking at E1 and E2, we see that the overlapped region ends at E1. In fact, it ends at the end time which is smaller. And we can notice now that if there is a conflict, then the common element x has to be between S2 and E1. This could be generalized as, for a conflict to exist, the maximum of S1 and S2 should be less than equal to the minimum of E1 and E2. The time complexity of this solution would be O of 1 because we are doing a simple check. And the space complexity would be O of 1. Let's implement our solution. Let's rename these variables to E1 and E2. We have to check if the maximum of the start times is less than equal to minimum of the end time. We could directly return this result. Let's submit our solution. As you can see, our solution is accepted. If you thought this video was helpful, please leave a like and subscribe to the channel. Thanks for watching.